Once we have downloaded and installed the threat modeling tool, when we open the threat modeling tool application, the first layout gets loaded. You can see a version number on the right top corner of the window. The version shown on the screen corresponds to the current version of application and threats in the software. Any changes made to the software or the threat library gets downloaded automatically when you open the application. There are two high-level applications in this software. One is the threat model itself, and the second one is the template management. The template management deals with adding new threats to the threat modeling tools library. I have separate video for the templates. In the threat model section, we have options to create a threat model, open an existing threat model, and option to read the documentation on the software. Let us select the option to create a threat model. For current exercise, we will not use a custom threat library, and let us select the default threat library provided by Microsoft. Once we click on the Create Model button, a screen opens. Sometimes it is empty and you need to navigate to view and enable the stencils and properties. Once you enable these options, we can see them on the screen. If you face difficulty in stacking the windows, you can drag and drop them in the right place on the screen to stack them. Once we configure the threat modeling tool software, the next step is to create the data flow diagram. The data flow diagram is created by replicating an architecture diagram provided by the development team. It is very important to ensure the architecture diagram provided by the development team is up to date and in line with the current product design. Let us create a simple threat model diagram. The architecture we are assessing now has a browser client that is communicating with a web server. To create the diagram, we have to drag and drop the architecture elements, also known as stencils in the software. As you can see, we can drag and drop various elements on the screen. Let us also add a file system to the architecture. The file system here is used to store local configurations. The user's data is stored in a non-relational database. We can rename the architecture elements to match the product's architecture diagram. Let us rename the browser to make it specific to Chrome. The next step in the threat model diagramming is to connect the elements on the screen using data flows. In this diagram, we will drag and drop HTTPS communication link from the stencil list. Once dropped, now we connect the ends of the data flow HTTPS to the architecture elements. Let us also add a link between the web server to the browser. This two-side data flow is optional and used when the data flow is bidirectional. Let us now connect streaming server to the database. The server writes and reads the data from the database. Hence, we do not create the bidirectional lines. Since certificate store file is updated by the streaming server over inter-process communication, we use an IPC link to connect the server and the file system. The architecture diagram is now complete. The next step is to add boundaries. Now, threat boundaries are some things which are it is a logical separation of the different elements in the architecture diagram. If we scroll down to the last section, we will find something called as generic trust boundaries, and then there are different types of trust boundaries. To draw a trust boundary, let's drag and drop the trust boundary here, and then we have to expand it in a way it covers the architecture element. Now, this boundary, we will rename the boundary as user users. Let's say it is something which is connected from the user's house, and also give some additional spaces to make it further good. Since this will be part of a corporate network, we can put all of this together in a AWS cloud, which is managed by the, let's imagine the organization is deploying the AWS cloud. This completes the creation of a simple threat model